Welcome to section 4.2 where we introduce logarithmic functions. Okay, logarithms are a little bit different from anything you're used to up to this point in mathematics because we're used to working with what I would call forward operations, multiplying, dividing, adding, subtracting. You compute the numbers, crank out answers for functions. Logarithms are actually defined to be an inverse, which makes them a little bit backwards way of thinking when you first encounter them. But here's the full-blown definition. So we've been studying exponential functions, b to the x for some base b, and we had some restrictions. You couldn't have 1 because 1 to the x was 1 for every x, and we wanted to avoid negatives to run into imaginary numbers. So when we looked at those graphs, they were always 1 to 1, which means they have inverses. But the inverse of an exponent is not one of our traditional operations we've seen before, so we have to define it to be this new function, logarithm. So they call it the logarithmic function with base b. You have a different one for each base. And so the notation that we use is, instead of f of x, we call it log of x. And sometimes we write parentheses, sometimes we don't. We do the same thing with trig functions, if you've seen sine x, cosine x, those types of things. So we have log base b. We use a subscript to tell the base because the base is very important for a logarithm. It's the inverse of a particular exponential function. So log base b of x equals y if and only if b to the y equals x. So what the heck does that mean? That means the log base b of an x is a number y that if you do b to the y you get x. It's the power of the base that will give you x. So one way to get used to that definition is to look at some of these numerical examples. Okay, so it says to try to do these without a calculator, just thinking about exponential functions and sort of reversing them for logarithms. So I always start with log base 10 of 100. And so to evaluate that, you have to think to yourself, what power of 10 will give me 100? 10 to what power is 100? Well, it's 2. 10 squared is 100. So log base 10 of 100 is 2. Okay? So if we look at part B, we would have to figure out what power of 3 gives me 1/3. And that's one of the exponent rules. 3 to the negative 1 is 1/3. Anything raised to the negative 1 is the reciprocal. What about log base 5 of 125? 5 to what power is 125? Well, 5 squared is 25. 5 to the third is 125. Okay. What about log base 4 of 1? 4 to what power is 1? Well, it's 0, another exponent rule. It actually doesn't matter what the base is. For any allowable base, if you raise it to 0, you get 1, so the log of 1 is 0 for all bases. And then I always throw this one in to start talking about domain. 10 to what power is negative 3? Well, there's no real number that'll do that because 10 to any power is positive. So the domain of logarithms are positive numbers. You can't put negative numbers into logarithms and get back real values. The textbooks always have a couple of other types of problems that are really, to me, just about learning the definition to practice going back and forth between logarithmic and exponential notation. So if you look at the definition of a logarithm, you have the logarithmic form, log base b of x equals y, and that's equivalent to the exponential form, b to the y equals x. So you want to be able to convert in either direction, and you really just follow the definition. Okay? So log base 10 of 0.1, or 1/10, equals negative 1. If we wanted to rewrite that, we'd start with the base, which is 10, and then the power is what the logarithm is equal to. So 10 to the negative 1 equals 0.1, which of course is a true statement. 10 to the negative 1 is 1/10, 0.1. Okay? And for this one, again, start with the base. 4, the number on the opposite side of the logarithm is the power. The logarithm is the power. 4 to the third equals 64. Okay? And then example 3, going in the opposite direction. Again, we're going to use the definition of logarithm, but in the opposite direction. So we can start with the base, and we'll have log base b. Again, the power is going to go on the other side. The logarithm is equal to the power, and then x would be the other number. So in this one, we're going to have a log base 3 of 243 equals 5. The 5 will go on the other side of the equal sign. And then we'll have a log base 0.5 of this number equals 6. So that's the basic definition of logarithm, and some examples of types of problems we do, really just to get used to that definition.